actually at CES, where he was taking that picture in the very beginning. And he asked me, hey, we have this awesome group in San Francisco that does these hack nights, and I want you to come down here and talk to them about what your lab is doing. The thing that's unique about our lab is we're actually in Michigan, and when it comes to brain technology, Michigan is not known for that. There is one laboratory there, and that is our laboratory. But we are a hidden gem, and we have some of the most revolutionary brain-computer interface technology in the world. And it's really changing the way people are thinking about the brain signals we're working with. So myself, I'm an electrical engineer, actually from the University of Washington. I'm also a soon-to-be PhD in about 2 months from the University of Michigan. And my PI is actually the mentor of the BCI Society. If you guys don't know what that is, it is the official society for brain-computer interfaces. And they also hold a meeting every 3 years called the BCI meeting, which is actually this year. And if you guys want to learn about brain-computer interfaces and that kind of stuff, definitely go there. It's amazing, and you'll sit next to some of the world leaders in brain-computer interface. You'll literally eat food with them, and you'll be staying in the same campus. You literally share rooms with them. It's so cool. It's like a family, and you're all part of it. The other thing, too, is I'm a CEO of a company called Neurable. Now, we're an early startup company, and we're going to be moving to San Francisco eventually. So, because this is where a lot of the brain technology is happening. Basically, what we're doing is we're bringing the algorithms that I developed inside the laboratory that I'm in right now, the University of Michigan Direct Brain Interface, and we're bringing it to consumer use in the gaming spectrum. We really think that neurogaming is the future, and a lot of the things that you guys have seen in neurogaming is usually very simple, one-dimensional applications, like moving a BB-8 forward and back, or meditation and concentration. So today, I'm hoping to blow your mind with some of the cool things we're doing at Michigan. So let's start off with our lab. So we focus on bringing brain-computer interfaces into the modern-day consumer world. We're actually the first lab to ever make a BCI talk like a keyboard to a computer. So this is called NBOD. It was actually made by Dr. Jane Huggins, who's the principal investigator of the lab. You just hook it up to almost any brain-computer interface system. For example, here we have something called a GUSB amp from GuberTech. And then the computer just reads it like a keyboard, which is really nice. It makes any BCI plug and play. It's fantastic. The other thing too is our lab was the first lab to ever combine Google Glass with brain-computer interfaces. Now that was really cool. We did this really awesome thing where we used the location-based system inside a mobile phone as well with the Google Glass, so that let's say that you have a severe disability and you went to a store and you wanted to get a shirt. Well, you can go next to the counter and find what location within the store you were at. And then we're able to, you're able to send commands to the brain-computer interface and ask one of the store clerks to actually get you a medium yellow size shirt and put it inside your basket. So we do all sorts of stuff like that. We're also one of the first labs to ever combine brain-computer interfaces with wheelchairs. So here you see, this is our old version of our technology, but it allows you to recline wheelchairs. And if you're somebody who has a severe disability, this is life-changing to you, because you finally have control of your own comfort, and that's really, really awesome stuff. The other thing too, let's see if this video loads, is we're also one of the few labs that actually works with gaming. Right now, this video is some of our older technology. I'll show you some of the newer ones near the end of the presentation, but in this one, a person's actually skiing, and it uses a technology called motor imagery, where you imagine moving to the right or to the left. Now, we experimented a lot with this kind of technology, and we found it incredibly limiting for people. And the reason for that is because it's very difficult to learn how to use this technology. And so I'm going to show you guys kind of what we did to move this along forward. So what do I work in particular? At the University of Michigan, what I focus my own work is on brain-computer interfaces that help children with severe disabilities take cognitive assessment exams. It's very simple. Instead of taking the test on paper, they actually just look at a computer screen and then they're able to answer using their brain activity. Now, why is this important? Well, believe it or not, almost about 42% of children who are in special needs cannot take these cognitive tests, and they basically govern their entire lives. So if you can't take this test, you may not qualify to get a wheelchair, you may not qualify to get physical therapy. If you don't get physical therapy, you'll never have the movement to actually take the test. And so you get stuck in this loop where a child is mentally all there, but they're not able to progress in life because they can't take this test with their hands. And so our technology enables them to take this test. And I'm going to talk to you guys a little bit about that because that's actually what I'm going to be demoing today. And I think what makes it most relevant is to hear from somebody who's actually suffered from a similar condition. So I got a video here, and I don't know if my speakers are loud enough. I guess it came out of the projector. Is that right? Okay. I thought he was helping me. Nice not.
The microphone.
I can do that. Let's see if I can try the. I guess there isn't a speaker on the projector. You guys hear that?
Still has a sense of humor and a PhD. Redefining disability is at the heart of Heidi's story. We've chosen to share it with the help of an echo, Heidi's friend Janelle Birch. The words you are hearing are Heidi's words, written responses to our questions, read by Janelle.
Strangers talk to me like I'm two, because they've made assumptions about my mental abilities based on their observation of my physical disabilities, and then seeing their reaction when they're introduced to me as Dr. Jens. That's always fun.
Heidi was one of the first individuals with a severe disability to ever earn a PhD. She is a researcher and professor at the University of Alberta.
I should be able to acknowledge the fact that I am disabled without fear that my life will be begotten by others. Sadly, this is often not the case in our society.
For 100 Huntley Street in Edmonton, I'm Megan Kelly.
So this is our laboratory to really help primarily children right now. But the way that our technology works, and I'm going to be covering this mainly because I want to show you, is that we created something called a hybrid brain-computer interface. Now, I don't know how many of you know what types of brain-computer interfaces are out there, but I'm assuming that half of you are novices and half of you kind of know the system. And so I will break it down for all of you regardless. So there's multiple ways of doing a system that's a brain-computer interface. There's something called motor imagery, where you imagine a certain motion, like moving your right hand versus moving your left hand. And then there's another system called P300 and steady-state visually rolled potential. Now, both of these are easier to learn than motor imagery, but they also don't allow for real-time control or for types of devices that are quick. The way P300 works is we actually, you can see here flashing rows and columns. And let's say you wanted to type the letter A. Well, if you want to type the letter A, you focus your attention on the A, and every time it lights up, you get this red line. However, if you focus your attention on any other letter, if any other letter flashes that isn't the one that you want to focus your attention to, you get the gray line. And so basically what we do is we look for the letter that creates this P300, that little red line, and then we determine that that's what we want to type. So for our technology, we actually combine P300 with another system called SSVP. Now SSVP works in a very simple way as well too. They're both based visually. So here you'll see that these letters are all flashing at different frequencies. When we're looking at P300, rows and columns are flashing at the same frequency. Here we see everything flashing at different frequencies. And so the way SSVP works is we actually have different choices. One of them is flashing at 30 Hertz, for example, another one at 20, 80, and 50. If you focus your attention on the one that has 8 Hertz, we'll actually see a spike in your occipital lobe area at the back of your brain that matches this frequency. And so we're able to determine what you're trying to select. So this right here covers the educational portion of this presentation. So,
We have a question.
yes.
Could you explain that a little slower?
Sure, not a problem. I think this, sure, not a problem. How about I go back to chill? Okay. So P300, the way that it works is, let's say we have these numbers in the corner. They all flash one at a time, where we do rows and columns. If I wanted to select the number 1, for example, I would focus my attention onto the number 1. And every time that the number 1 flashed, changed color, I would get the red line that you see up there. For any of the other numbers, you would get the black line, which is just your normal brain activity. So we say which one is time locked with that red signal, and if that is, and from that we know what they're trying to select. SSVP, we did it using these checkerboard patterns on the outside. Each checkerboard flashes at a specific frequency, but they're all different. And so then we look at the brain activity and we say, do we see this frequency in their brain activity? And if we do, we know they're selecting down. Does that make sense?
Yeah,
Excellent. Cool. Excellent. Feel free to interrupt me and ask questions all you want. No problem.
How long does it take for that process to happen? Is there a lag?
Yes, there is a slight lag. When it comes to SSVP, it can take about 1 second. And when it comes to P300, it really varies about person to person. It can take sometimes 1 second, sometimes 20. It really, there's a lot of variance there.
Where is the lag coming from?
Actually, the majority of the lag is from signal to noise. So usually when you do P300, you have to take these averages of P300. So you have to flash multiple times and then take an average. And so that's where you get a lot of lag. Yeah, the brain response is actually, for the P300, is actually 300 milliseconds on average. And that's why it's called P300. Positive change 300 milliseconds after the flash. So those are great questions. And it lets me pretend a little bit more that I'm a neuroscientist. So here you can see how we combine them together. The numbers on the inside is P300, the outside ones are SSVP. However, like I said, we work with kids who have severe disabilities, and so when they're taking these tests, and this test that I'm showing you right here is actually called the Peabody Picture Vocabulary Test. It's used to figure out the vocabulary level of a child. Now, they need time to think about this, especially if they have some sort of brain injury like cerebral palsy. And so we actually develop algorithms in our laboratory that let us do that. One of them is called certainty. And basically what it does is it makes certain that you want to make a selection. It prevents false positives. And the reason I'm telling you this is because this is going to be important moving on to the next half of my presentation, where I actually talk about the company I'm starting up. And then, and you'll see this in the demo, you'll see that eventually what happens is all the images but one dim out. And we do that in order to tell the child, are you sure this is the one that you want to pick? The one that's colored is the one that we think the child is trying to pick. And then we use a second brain algorithm called hold release that does real-time confirmation. And this is really one of the biggest things our laboratory has done. Now normally, as somebody mentioned back there, what is the slowest part? The slowest part is that signal-to-noise issue, and we have to take averages. Well, hold release allows us not to take averages. It basically cleans up a lot of the data and allows you to do real-time confirmation. What that means is that you're now able to do real-time applications using the P300 signal, which, is on the neuroscience side is awesome. It's like really cool. It now creates a whole new avenue for which you can use this P300 signal. Xiaoya, I don't know if you're back there. If you want to come up here, you can actually show them how it looks. So this is Xiaoya Ma. She is the Chief Science Officer of our company. She will be showing you a little bit of how our technology looks like. And if I'm going over on time, I apologize.
Hi everyone, my name is Xiaoya Ma. I was a PhD at the University of Michigan. I graduated last year with exercise physiology degree. Then I went to medical school and I'm doing postdoc over there. And I was involved in this technology 2 years ago. And I think it's really amazing. And it's going to be really helpful for people who have disabilities. But we also want to bring this to the consumer side so people can use this kind of technology for gaming, other different kind of things. We're also going to he's going to talk about more about the technology. We hope in the future everyone can use this and do whatever heck you want to do.
Okay, so basically what we're going to do is Xiaomi is going to do this, the test that we normally give to children. Now, you'll notice that we don't have the checkerboards. We actually removed the SSVP component in our later versions. So you're seeing the most latest one that we usually give to children. And then this is what we do in our laboratory, basically. So you're actually going to see her make selections using her brain activity. So she's supposed to be picking number 1. So the first algorithm you're seeing here is called certainty. And it's basically not going to make a decision until we are certain that she wants to make a selection. And normally it goes a lot faster than this. So.
Is she looking at one or is she thinking about one?
That's not right. What's up? She is focusing her attention on one. It helps if you look. Bike. And it doesn't seem to be functioning for you guys right now. Which is funny because we tested it here at 6 and it worked perfectly. So
they're not tracking her eyes in addition to just tracking her
okay.
neurological response.
Yes, her attention. What she wants to focus her attention to. So we'll try to get the number 4 here. What's that?
Performance anxiety.
What's that?
Performance anxiety.
Yes, right? There we go. Now she selected bike. There you go. But you notice that they grayed out. That is the home release system that we're showing. You can just select the dog. Oh, alright, well, I guess it is performance anxiety.
Could you explain all the release I don't right?
Yes, not a problem. So you can see right here that there's this flashing going on. So normally what would happen, and you'll see it in a second, when they're all colored, that's the normal amount of time that it usually takes for you to make a selection. And you can see it's a little bit slow. Then when you see them gray out, we actually use the home release system to do real-time confirmation. And so you'll see how much faster it is right here. See how fast that was?
Does that mean that she switches from the number to looking at the X?
No, she still looks at the number.
Oh, still isn't.
Only we verify that she wants to select it actually 4 times in that small fraction of time. So by verifying, what I mean is we're making sure that her brain activity agrees with the selection that she's trying to make. Yes. Normally that we would have to do 2 cycles of this flashing.
So you can just reset putting the P300 over and over again, and then using the X to cancel that? Is that the...
That is, yes, that's one of the things that you can do. Yes. Yes. But here we're doing it so that she can just make selections on the screen. And I'll show you a little bit more about the hold release in the later half. Yeah.
I was asking, so how's the selection verified? What is she doing to verify the selection?
She's just making the same selection.
Okay, so that's in the background, so to speak.
Yes.
Okay.
We try to make it as seamless as possible. But you will see a better example of it coming up.
Are you allowed to talk about it, or is that secret sauce?
What's up?
Are you allowed to talk about it, or is it secret sauce?
Some of it is secret sauce. I will talk about the parts I can talk about. And then afterwards, of course, if you guys are interested, I'd be happy to chat with you guys more about it in person. And if you guys want to do some hacking on it or see some of the stuff that we're doing on there, you're welcome to do it afterwards. So this brings me to the actual company end of things. The reason that I'm here is actually... Is that my time? Is it over? Is that where you're going? So the reason I'm actually here is because of Steve Castellati. I met him in 2012. A lot of the community that I know is because of him. We actually met at the BCI meeting in 2012, and he saw some of the technology that we're doing, and he said, hey, why don't you come down to California and just come hack things with me? So randomly he would call me, and then randomly I would go over there and we would do these really cool hacks. So this right here was one of the hacks that we did, and it actually uses the second version of the whole release system. Now, when you guys saw that flashing, did you guys see how long that took? That took a really long time, right? That was like 10, 20 seconds sometimes, right? So can you imagine using a wheelchair and having to wait 20 seconds for the wheelchair to stop? Like that kind of stuff would be horrible. That's how you die, guys. So this is actually in the pseudo room, and this is the first time we actually tried hold release in an actual device. Now I have a video, but this one we didn't actually get the brain activity going, so that's what brings us to 2015. Steve actually called me up once again randomly, and he said, hey, Discovery called me. Why don't you come over here and we'll hack a car, and we'll see if we can get it to work with our brain activity. And so I said, yeah, sure, why not? So I took a flight over there. We had 5 days to do this hack. We actually had to use a hand drill to control the steering wheel, right? We had to use a small servo here to actually to press the gas pedal and the brake pedal. And you see a picture of me sitting in the back of the car. Now, what's funny is I refused to sit in the back of the car when we were actually doing it. So we devised a wireless system to actually send the commands to the car wirelessly. So I'll show you guys how it looked. Now, we did get it to work eventually. Unfortunately, that was after they left. But it was a work in progress, and it showed a lot of proof of concept. And that's really what brought us to NeuroTechSF. So what we did in our laboratories, we said, hey, this technology has a lot of potential. We're finally able to do something that used to take 20 seconds to a minute sometimes, and do it in about 500 milliseconds. Transformative neuroscience right there. It's a huge disruptive step. And we said, why don't we create a company and try to not just use the intellectual property in our laboratory, our secret sauce, but also combine it with what's out there right now and create the future of gaming itself. And so what we're planning on doing is actually developing a software development kit. And like Shai was mentioning, this is going to be something that's going to be available to you guys. But really what our technology lets you do is multi-dimensional control. So if you guys remember, I don't know if you guys have seen the famous video of the BB-8 moving forward and back using brain activity. Well, now imagine moving BB-8 in all directions. Right? So our technology allows you to do that. It's very fast to respond. It's about 500 milliseconds. It also does state detection, so stress, concentration, and motion. And this is what I think is going to be one of the most impressive parts. We're designing a training element that requires little to no training for the applications to do. So you can just put on your headset and then just use it, instead of having to sit in front of the computer and learn to train and try to learn your brain activity. And the reason we do this is because we envision a future where you're playing the Luke Skywalker games and you actually feel like you're using the Force. So you're able to combine our P300 technology with some of the technology that enables you like push and pull with your brain activity and really feel like you're there. Or imagine controlling a drone in like a game like Call of Duty, and all you have to do is just use your brain activity to do it. This is the kind of technology we want to bring, and this is the kind of stuff that we've been able to show with our tech. Or even the stuff that Steve is doing with Puzzlebox, where he has a helicopter that goes up and down, and now you can actually move it around in 3D space. How cool would that be, right? So this is how we imagine it. You get whatever headset you want. Then you get our software development kit, and you just create awesome things. This is for the creators and for the makers, and the best part is it's free for you guys. It's free for anyone who wants to make things. And then if you do make something, you decide to commercialize it, we'll be getting a % revenue because we also need to make money. So I got to pay for my own lights too. So to kind of show you how the system looks like now compared to where you guys saw it with the car, I want to show you that right now. So here we actually see Xiaoya controlling a Mickey Mouse in 3-dimensional control using all real-time brain activity. And you'll actually see me say something and she'll do it almost immediately. So that was up. Look at that. And then here's an even cooler example coming up. Real-time Lego Mindstorm control, multiple directions. Right? Even way below to all of you right now today. Look at that. How cool is that, right? This is the transformative stuff we want to bring, and also combine it with other brain technologies that are out there to truly create the next generation of brain-computer interfaces. Now, we actually started the company just a year ago in 2015, but man, we work hard, we're doers, we're go-getters. That's the one thing that Michigan definitely does. We work really hard. We're actually on our 6th software prototype and our 4th hardware prototype. We're working with a company called Wearable Sensing, but we're also looking for other headset manufacturers to create just a small band that you actually wear at the back of your head. And then you're able to do all the cool things that I just showed you. Right now, we're actually transitioning from being a university-based technology and actually commercializing a product which we plan to do by 2017, and we're currently in our seed, which means we're trying to raise money. What it means to you guys is that we're actually looking to move to San Francisco, and we're looking to hire people in data sciences, game developers, animators, and experts in brain-computer interfaces. And so we want to bring this technology as fast as we can out there to all of you guys, all you makers, all you creators. And we're looking for you guys to also provide your skill and your passion. Because if you guys aren't here, I mean, you guys are here because you're passionate about neurotechnology, right? So that's what we want to do. And we're also looking for connections and to create a network, talk to people in the augmented reality and virtual reality space. So with that, I want to thank you guys for your time. Really appreciate it. If you guys have any questions, please let me know.